Okay, we're going to take a look at more with complex numbers. And today it's going to be taking a look at like how we can add them, subtract them, what happens with them. So kind of a big thing to know here is it says all numbers fall into a very broad category known as complex numbers. Okay, and complex numbers here can always be thought of a combination of a real number with an imaginary number. This is not working. Hold on. So we got a real number here with an imaginary number. Okay. And it says where A plus BI, where A and B are real numbers. So take a look at that notation. Okay, so that notation here, so we have A and we have B, and that A and B are real numbers. I is not. I is imaginary. So when we do this, it says, we say that A is the real part of the number and BI is the imaginary part. Even though B is a real number, I is the imaginary part. So you put it together, that's the imaginary part. So these two parts, the real and the imaginary, cannot be combined. Okay, so there's your apples and oranges. There's your X and Y. You can't combine them. Like real numbers, complex numbers can be added and subtracted. The key to these operations is that the real components can be combined with the real and imaginary with the imaginary. So the A with the A and the BI with the BI. That's what we need to remember. Okay, so for this first one, we're finding the sum of this first one. So I'm going to take the A with the A. So I have a -2 plus 6. I can combine those. And then I have a positive 7i plus 2i, and I can combine those. So adding that up, I'm going to have a total of 4 plus 9i. So constants with constants, I values with I values. Now, we just have to be careful here because of this minus. Keep in mind, we are subtracting both the 2 and the -7i. So watch your signs. Okay, so I'm going to have 5 minus 2, combining those guys. And then I'm going to have a positive 3i minus a -7i. I'm going to combine that. So 5 minus 2, I get 3. 3i minus a negative, so that's really plus a positive. So 3i plus 7i is going to get me a positive 10i. So you just got to remember the A value with the A value and the BI with the BI. And you don't do anything with the I's. The I kind of works like it would if it was X. So if we did something here and it was like 3x plus 7x, we get a total of 10x. Notice how that's the same thing with the I. Treat it just like you would a variable. Okay, so we have another one. What's the sum of 6 plus 2i and -8 minus 5i? So again, you could even do it this way. Here's another way that sometimes it's nice and easy to set it up. Kind of like back when we were in elementary school. You would, oops, how about that's minus? Just line up your values. And now since we're adding, just going to put a little plus sign out there. Then we're going to add them up. 6 plus a -8, I get a -2. Over here, 2 plus a -5, we have a -3. And those are I values, so we got an I there. So you have -2 minus 3i, just a different way that you could combine them. Okay. So it says adding and subtracting complex numbers is straightforward because the process is similar to combining algebraic expressions like we set up above. Complex numbers are closed under addition and subtraction. All that means is that if you add a complex number, you get a complex number. If you subtract a complex number, you subtract or you get a complex number. You're not going to get anything like a real number or something else. Okay, so then the question is multiplication closed? Meaning, will I only ever get a complex number back if I start with complex numbers? All right, well, let's see what happens. We're going to find the products. So remember, this is FOIL. This is just FOIL with imaginary numbers. Okay, you can FOIL everything or double distribute everything. Okay, so 3 times 7, we get 21. My outside terms, so 3 times 2i, just like we would if it was like 3, if I did over here, let me do it up here, 3 times 2x, I know that I would get 6x, same thing here, 3 times 2i, I'm going to get 6i. Okay, over here, 5i times 7, I'm going to have 35i. And now my last term's 5i times 2i. Okay, well, what if it was an x? Well, we would do the 5 times 2. That would get us 10. The I times I would get you I squared. Ooh, we know what I squared is. Okay, so we're going to have to simplify. So we have 21 plus, let's combine these. So I have a 6i plus 35i. So how about 41i? And now I have plus 10i squared. Well, I squared is really -1. So this is saying 10 times -1. 10 times -1 is a -10. Okay, so now we can take this one step further, combining the 21 and the -10. So 21 plus a -10, so how about positive 11 plus 41i? So notice what happened. We get back a complex number. So we started with complex numbers, we get back a complex number. Okay, let's try another one. So I have 4i, or 4 plus I times -5 minus 3i. Same thing, we're going to do a little foiling or distributing. Okay, so 4 times -5, I get -20. Outside terms, 4 times -3i, how about a -12i? My inside terms, I'm going to have a -5i, and my last terms, I times -3i is a -3i squared. Okay, so we're going to combine like terms. So I have a -20, -12i, -5i, how about -17i? And now over here, we have a -1, right? I squared is -1. So -3 times -1, this is really going to be a +3. Okay, so if I combine one more, -20 and the +3, that's going to get me a -17 minus 17i. So far are still getting complex numbers. Okay. So we're going to take a look at this. And we're still going to try and put this into a plus bi form. Notice what we're doing here. We have to FOIL this first set. We have to distribute the 4i to the 2 and to the 3i, and then we're going to have to combine. So we're just going to watch what we're doing. And since this is with addition right now, we don't have to worry too much about our second term. If that was subtraction, you'd have to be really careful. Okay, so 5 times -3, we're going to have a -15. Our outside terms, we're going to get a +5i. Our inside terms, I'm going to have a -6i. And then our last terms, 2i times I, I'm going to have a +2i squared. Now what I'm going to do is just kind of put this in parentheses for right now, so that I know that that's my first step. Let's go back and let's do this 4i and let's distribute that. So 4i times 2, I have 8i. 4i times 3i, we're going to have 12i squared. Okay, and this is all one group. Okay, so now let's combine like terms. So in this first one over here, I have a -15. I have a +5i and a -6i, so that's -i. We have 2i squared. Remember, I squared is -1. So if I multiply those, that's really a -2. Okay, and if I keep working with this and simplifying this down, -15 and a -2, I have a -17 minus I. So that's this whole first group here. To that, we're going to add. Now we're going to combine this, but remember, I can't combine these two, but I do know that the I squared is -1. So if we simplify that, this second term is really going to be -12 plus 8i, keeping it in that a plus bi form. Okay, so now we have to combine this and we have to combine this, because remember, we're adding back here. Okay, so I have, and again, it's up to you how you want to do it. I'm going to write it one on top of each other. So I have a -17 minus I, plus I have a -12 plus 8i. right? And we're going to combine. So I have a negative 17 and a negative 12. That's going to get me a negative 29. I have a negative I and a positive 8I. That's going to get me a positive 7I. Okay, so we just had to be careful with our organization, keeping in mind we're adding right back here. We were adding. This is where that's coming from. We're adding from here. All right, if that was subtraction, you'd have to remember to subtract or distribute that negative. Okay, so far we're still multiplying and adding, and we're still getting complex numbers. So it says show 5 plus 2i times 5 minus 2i would simplify to be a purely real number. All right, so we're going to do that foiling again. So 5 times 5, I get 25. My outside terms, 5 times negative 2i is negative 10i. My inside terms would get me a positive 10i. And my last terms would get me a negative 4i squared. So notice this middle part right here, positive 10i, negative 10i, that's going to reduce out. So now I'm left with 25. Over here, my I squared is negative 1. I have a negative 4 times a negative 1, so that's really a positive 4. And then if we simplify this, I get 29. So that's interesting. So there's a chance or a case where we're multiplying and we have two complex numbers, but we actually get a purely real number back. And it says, why does this happen? Well, these are complex conjugates, and we have talked about these before, where you have the same term, but one is adding and one is subtracting. Okay, so with these complex conjugates, anytime you have something like that, that middle term, which would be the I part of the term, drops out. And so everything else is going to be a purely real number, because you would get this I squared in the end over here. And with that I squared, that's always going to reduce down to negative 1, which is going to get us a real number. Okay, and with that, we're done with our complex numbers. So I hope that was good. If you have any questions, please bring them to class. I will help you with them. And otherwise, I hope you guys have a great day.